Let's burn up a lot of time. I'm going to go very quickly. My name is Martin Peacock. I do recognize the names that have come this afternoon, so thank you so much for coming. We will be efficient with your time today. And I do want to say thank you to Ghana, who's also here. So Ghana will be doing a live demonstration, and we'll do a live demonstration because it kind of illustrates the robustness of the technology stack. I suppose it's worth saying that this technology stack that we're talking about, it's kind of intended for OEM kind of relationships where we may be one of the technology providers, but you may be essentially taking it to market or taking it further towards the market. But let me describe what we've got. Now, it says here sensor to API. When I started my career, API meant active pharmaceutical ingredient, but in this case, it means application program interface. So ZP, we do think we're part of the kind of digital. We do think that we're part of the sort of digital infrastructure, where if ZP is a conduit for chemical or biological or biochemical data, this data is going to go to the cloud, and other people can call upon that cloud and essentially add value to the data. But I'll describe that as we go forward. I'll be quick and just say, just a brief introduction to ZP. The font's slightly small, but we were launched in 2014. We are ISO 13485, so most of what we do is contract development, contract manufacturing in medical diagnostics. And in doing that, we've always tried to ask the question, how can we get people to market or get products done quicker, essentially? When I started my career, this was in Abbott in about 2000, making glucose strips. I kind of realized that every time you want to do a new product or a new technology, you're essentially building everything from scratch. So at ZP now, we've put a lot of the components together. So it feels more like a sort of app development now that, what are these new applications that we can work upon, as opposed to let's have to rebuild the whole technology stack again. So that's our kind of mindset. So we are ISO 13485. So we're pretty good at documentation and adhering to it because a lot of what we do is actually done into the human health. We are contract developers and contract manufacturers. We're not big, we're not small. We're small medium in terms of footprint, 4,000 square meters. We're in Norway and the UK primarily. And the team is international. There's something like sort of 23 languages spoken within the ZP team. Our facilities are state of the art. We've obviously got modern facilities, class 7 clean rooms, class 5 zones. We're a kind of an unusual company because we will talk a lot about technology today, but when you look at us, there's science labs where we have material scientists, chemists, biologists, electrochemists. So we do a lot of wet chemistry, pipetting, solutions around the place, growing microbes, all sorts of interesting stuff. And the facilities, as I say, are quite modern. We'd also have both a manufacturing site and an R&D site in Norway. And in the UK, then we have some labs in Coventry. This is kind of in the heart of the UK. And we have a small office in South Wales, in Swansea. The platform that I'm going to talk about today, we call it Sense It All, and it really means something, this Sense It All platform. So the instrument looks quite elegant, and it does look elegant, not quite elegant. It does look elegant. And Guyana will do you a real-time demonstration of it. That term Sense It All, what it really means is you'll see us position the technology to do different assays just by using a QR code. But in the end, the instrument, and this is the primary instrument that we'll be talking about today, this Sense It All, as I say, I put OEM here because we really see that actually to get this sort of technology out among different people, there's different markets out there. For example, there's veterinary markets, there's food markets, there's agriculture markets, there's aquaculture markets, there's there's process markets. All these markets, they have different pains and different buying processes, and there's different people. So you can't do a big penetration unless you partner up. So that's why I deliberately use the term OEM there, original equipment manufacturer. So we think we're part of the technology stack. And we do a lot of wearables. So at ZP, the heart of the science that we do is electrochemical. Every glucose strip in the world is electrochemical. Electrochemical is a very good way of manufacturing sensors and manufacturing assays at quite low cost. If you look at, and when I say wearables, if you look at, there's something called CGM, continuous glucose monitoring. So you see people walking around with patches on their arms these days. Those are electrochemical glucose sensors, and that's part of our sort of technology portfolio. But I will be focusing in on the central instrument here today. As you can see, every month we just do a live demo, and I like to do the live demos because people talk about their stuff, but when you see it, then you can understand actually how robust things really are. Especially in the technology world, things don't work, things break down, but we like to do the live demos because it really kind of helps to demonstrate that kind of robustness. Now, online today, I recognize many of the names. There's companies that are, several billion-dollar turnovers. There's startup companies. There's academics here. So what our philosophy at ZP is, look, there are people. Here I've to put an image of, sort of a farmer, but I could also put somebody interested in water purity as well. A patient. There's some analyte that if we measure it, we can improve either the kind of the margins for the farmer or the health outcomes for the patient. And then on the left-hand side, we really have entrepreneurs, business people, academics, people who want to provide solutions. Now, the problem is that often, in order to kind of provide a new innovation, you have to end up developing the hardware. And at least in the world of point of need testing or in vitro diagnostics or point of care diagnostics, these are terms where when I use these terms, I'm thinking about a handheld device with a sensor. The sensor, you read an analyte or analyze a sample and you expect to kind of throw it away. As I say, when I first started my career, if you wanted to make a product along those lines, you essentially built it from scratch. And now we're sort of saying, no, actually, we do have some hardware. It's extremely flexible. We can manufacture it. And we also manufacture a lot of electrochemical sensors and also something called screen printed electrodes. So for my academic colleagues, they'll be more interested in the kind of screen printed electrodes because they can build new assays on those electrodes. For the guys who are kind of more interested in things like aquaculture, then we have things like sodium sensors and potassium sensors and calcium sensors. And then you can also use conductivity for looking at salinity. They're more interested in actually the sensors themselves. But what we're interested in really is getting people with ideas able to provide solutions to the end user as quickly as possible. Now, what's good about the technology stack is that we have a cloud system called Julie. You will see Guyana do this today, that in real time, she will do a test, but the data will essentially via her smart device go straight to the cloud where we will actually store the raw data. And this is important because by having Julie, we get the raw data, which means we can do online quality control, we can troubleshoot, otherwise you kind of get a number on a device and everyone says, oh, I'm not sure about that. Are you sure about it? Well, with us, actually, we can see the raw data so we can really back up or help troubleshoot, what may be happening in the field. So if you're a developer or a company on the left-hand side, you're not necessarily excluded from seeing what's actually happening in the field because our technology stack is already cloud connected. It also has an API on it. That's why I sort of started this webinar with this kind of comment, sensor to API. I could really back that up and say we probably sample to sensor to API, but sensor to API, and the API just means that the cloud that we have today, you can make calls upon it and bring that data across to another server. So an example of that would be you were measuring nitrate in soil in some sort of farm, and you wanted to kind of correlate that then with something like rainfall. So you could get rainfall data via an API. So you'd have a kind of data from us via the API, you'd bring rainfall in, and then you could sort of mesh that or fuse that data together and kind of add value and insight for the end user. And then by seeing the data, if there's something wrong or the algorithms for converting raw signal to information could be improved, we can do that through the clouds. And essentially, we're in this iteration of trying to do improvement. Now, especially the guys in kind of California and stuff, you would recognize this term lean startup. So really what I'm applying here is kind of lean philosophy of doing things fairly quickly and getting them into the hands of end users and then getting their feedback in order to iterate. Too much happens that when people actually put quite a lot of investment in building a technology, then taking it to the customer and finding out it's not quite what the customer wants, and there's been a kind of whole wasted effort. So we're very keen on accelerating that MVP, that minimally viable product kind of strategy. So SensiAll, this is the way the hardware looks today. Guyan will show you that it's got a very nice user interface in terms of, it's small, it feels quite weighty in the hand, but it's got LEDs on it, and these LEDs kind of guide the user experience. You turn it on, there's a green LED. When it's ready to make Bluetooth connection, there's a solid blue LED, there's a flashing blue LED, there's a green LED for showing that data's collecting, and there's a LED to show that the data's actually gone up to the cloud. So the user experience is quite nice, and it's physically a nice object to actually look at. So we're not trying, even though we come from a medical background, we're trying to give a look and feel that's much more, I say, consumer friendly. This is, I don't want to say, I will say it, it's much more of an Apple style product than a typical kind of chemical analyzer, when in the end it's a biological, biochemical and chemical analyzer. And as I say, just a side note, the reason we can make this bold statement SensiAll is because I did mention it, that the key science or the core science at ZP is electrochemistry. It doesn't matter, guys, but the techniques that, for example, if you're making a glucose measurement, they're often they're often amperometry. So we have the ability to run amperometry on that device. If you're making a pH measurement, then it's potentiometry, or they're ion selective electrodes that run in a potentiometric mode. If you're trying to measure potassium in a dialysis patient, that's potentiometric. So we have potentiometry. If we're trying to measure something like capsaicin in a chili sauce, then we use a technique called voltammetry. And if we're trying to make an immunosensor, so you're trying to do virus detection or bacteria detection, you often use antibodies. These antibodies are immobilized on our surface, and when they attach, the resistance or the impedance changes, and therefore we use impedance spectroscopy. So that little box, and you'll see it with in some videos and in Guyana's hands in a minute, is actually able to run all of those techniques. But we want to give people a really good user experience, so we do not show them the voltammetry or the impedance spectroscopy, because that's not what a food scientist or a clinician wants to see. They actually just want the number, but we do get the raw data. Let's be clear about that. Now, there are just a few academics online today, because I'm also very interested in addressing this sort of problem in academia of when people are doing the fundamental research, they have these large instruments. This one happens to be, it includes an impedance impedance spectrum analyzer. The problem with it is it looks nothing like a product. So this is just a side note to my academic colleagues, that even though I'm talking about SensiAll this afternoon, we can do amperometry, voltammetry, potentiometry, impedance spectroscopy. Secretly, nobody cares about these techniques. They just want essentially it to work, and to work in their particular assay or their particular application. We do to a potentiostat called Kate, which is exactly the same hardware, exactly the same electronics, it's just different software. So for the academics, just know that you can now develop new assays upon something that's also, we're able to offer it out to the commercial market. So there's a very quick transition or translation from do something in the lab. It's done in a sort of, you may make a differential square voltammetry assay, but we can translate it very quickly onto the SensiAll platform as well. Now, when I say the price here of this is $60 US, I am talking about selling volumes of 10,000, at which point it then gets the $60 US dollars. And I've got a couple of links here, and I'll try to remember to put those links. Now, and if by attending today, and if you've got colleagues who didn't attend, don't worry, I will send out a recording of this afterwards as well, along with the links. The way the technology is actually running is we have a sensor, and we have a series of platforms, or wearable one, a spectrochemical one, and an electrochemical one. I am going to talk about the electrochemical one this afternoon. It's the app. There's something called the SensiAll app. It resides already on the Android Play Store. That app is essentially what I would call a distribution app. It's something you can download on your phone. I'll probably do a demo of that, in fact, in a minute. That app will tell the hardware what to do. The hardware will run the assay. The hardware will give the raw data back to the app, and the app will process it and turn it into a number, but also send that data to the cloud as well. And I'll try to illustrate that with a few arrows in a minute. So sensor goes in hardware. sample goes on sensor. Sensor doesn't know what to do unless the app tells it what to do, but that's a really good thing because we can go between calcium, potassium, pH just by using different QR codes. So app tells hardware what to do, hardware gives data back to app gives it to Julie, which is really useful for us because this opens up new business opportunities because you get the data. So you don't have to just, sell sensors and hardware. You can also sell data as a service, or even turn it into real information as a service. So you get the results, but importantly, we get all of the raw data in the cloud as well, not just the numbers, but the whole raw data. So this is very useful because if you're doing, let's say you made a sensor for fresh water, and then you thought, right, actually, I want to put this sensor into pool applications, and now in pools there'll be chlorine. So you want to kind of look at those raw signals and make sure that the chlorine or wherever they're treating the water with is not causing interferences. And we could do that by actually just looking at the raw signal. So it allows you to get into new applications. And then if there is a new interference, we can try and subtract it back out of the signal to get back to accuracy. And it's really useful as well because once it's in the cloud, you can share it with people like us, and we can be part of the kind of the application exploration or the development journey. So sense it all. Sensors, sample on sensor goes into meter doesn't know what to do unless the app tells it what to do. The app tells it what to do, the app gets the data back, and it all goes up to the cloud, and you can give a result in real time. Don't worry, I'll also, and there is an API as well on the cloud as well, so you can make calls upon it. Just a couple of videos just to which will something that Guyana will show you anyway. One of the videos is about the hardware, one of the videos is about the system, and one of the videos, which is I think one of the key points to this, is in the phone, in the bottom video, I'm actually showing that by looking at different QR codes, we can tell this sensor do a TAS measurement, which is TAS is total antioxidative status, or we can scan another code and it will actually then run the nitrate assay. So the app is like a distribution app, but once you've got the app on your phone, then it then says scan the QR code. You scan the QR code, and it will tell the meter, look, you're going to run this kind of assay, and the meter will run that kind of assay. This is quite nice because one of the problems with instruments that come from companies like ZP in the past have struggled because actually we make them like engineers. We think like engineers, but real people, they don't want to be slotting sensors into little slots, and there'd be a risk of liquid getting into electrical connections. These are the kind of problems that people have had traditionally with the kind of hardware that we're interested in doing, but we've made it very nice. Guyana will show you this, that you can just put these sensors in there, they self-align, you click it up, it makes contact. If you make a little bit of a mess, let's say, you can actually just take it apart, clean it, and reassemble it, which I'm doing in the top left-hand corner of that particular video. In that, we do have a lot of sensors. I mentioned glucose at the beginning, but we have glucose sensors. Happens to be amperometry. Nobody really cares, but the instrument can deal with it. We have nitrate sensors. Happens to be potentiometry. Nobody cares, but that is the case. Potassium is the same. It's potentiometric. And then we will have sensors like troponin I, which is a cardiovascular marker. That's impedance. And then we'll also show you some voltammetry assays today as well. So we do have a bunch of pre-made assays, but if you're coming from a position of actually wanting to develop your own sensors, you're also not excluded from the platform. It doesn't have to be something that we've actually done the development on. What's underpinning all of this? This is a bit boring for some of the guys who are more commercially interested, but we definitely manufacture these little disposable sensors ourselves. You have to manufacture themselves because we have to really take care of the quality. You can watch this video later on when I send you a recording, but if you scan this QR code or for like an Android phone, it will bring you to the Play Store. You can install the app, and then when you've installed the app will actually ask you to scan a QR code. So if you scan this QR code, it will ask you to run the chili sensor. If you run this, it'll be the ginger sensor. Here it's the nitrate sensor. Here it's the TAS sensor. So Sense It All means we are literally dealing with more than 40 assays. And for each application, there'll be new challenges. I must definitely mention that. We have a bit of a landing page for it, so I'll skip over that. What's quite nice as well is the business model. So if people are able to use our Sensi.all platform, we really take care of the operations side of the business as well. So it can be you, it can be a business that you're creating, or it could be a business that you're in. You have a client. I think the hardest thing in business that everyone overlooks is how hard it is to find real problems that people are willing to pay for. So we don't underestimate that challenge. So there's you and there's the real clients, let's say, at which point a sale is made, at which point a sale becomes really an instruction to us. And the instruction to us is get those sensors, get the hardware, put them in a box, and drop ship it then. And we're a fairly international company, so we're quite used to shipping around the world. The reason I bring that up is, especially if it's a startup, you can end up needing something like 3 to 5 people in operations just to do order fulfillment. But the nice thing about this model I'm talking about is order fulfillment is something that we already do. And so you can just piggyback on the back of our essentially operations or our logistics, and then we'll drop ship it around the world. So in this conversation so far, I've said, we're trying to minimize the technology gap between an idea and actually making a product. And we're also trying to minimize the operations gap, the business operations between an idea and order fulfillment. So that is also part of the model as well. Now I'm going to quickly go to demo. And if you're coming late, don't worry about it, because we have recorded this, and we will share the video afterwards. What I'm going to start doing now is asking Gayana to unmute, share her camera, and Gayana will be sharing her screen, and then she'll do some demonstrations, and I'll do a little summary at the end. So I'll stop sharing, I'll stop my camera, I'll stop my microphone and say hi, Gayana. Thank you.
Yeah. Hi everyone, I'm Gayana. I'm an engineer here in Zimmer & Peacock, and I'll try to show you our Sensi.all platform. I'll just go ahead and show you what I have with me. So first of all, I have the device with me, and as you see, it's quite small. It fits in my palm. It has USB-C cable, which I just need to connect to the power. It has a power button. It has LED which shows if it's powered or not. And also there are some LEDs in front to show the state of the device. It also has this movable slot which clicks up and down. And we will need to place the cartridge here and click it up to make the connection between the sensor and the device. And we will be able to run some measurements. Now what I have with me is QR code for ginger sensor and a chili sensor and a ginger sensor. And I also have some sensors with cartridges and 2 different solutions to test. First one is the chili powder mixed with a chili pod buffer with 1:100 ratio. And the second one is a ginger shot solution, again mixed with a buffer with 1:10 ratio. I'll just maybe jump ahead and start with the demonstration. I also have Android phone with me. The first thing that I will need to do is to scan the QR code. It's right here, and I will scan the chili one first of all. And then I see that app is set up for the chili sensor. It shows the sensor batch ID and sensor part number. It also says the assay steps, like how many steps do we need to do to run this assay. The next thing that I need to do is to connect with the device. For that, first of all, I need to connect the device, and I will power it on by pressing this button for approximately 2 seconds. And I see that there is a LED light here that shows that power is on. And I see that in the front, it's blinking blue light, which means the device is ready to be connected with Bluetooth. I'll go back to the app, and I will click this button on the top of the device, which says connect the device, and there is a Bluetooth icon. I'll click on that, and now I see all available devices. So this particular device has the serial number of 1003. I will click on it to connect. This is, it takes approximately a couple of seconds to connect, and now I see that device is connected. I can verify by checking the LED light. It will be white. And I see that it's on the mobile app, it says the device is connected, and I can see the serial number and MAC address of the device itself. And okay, let's start with the test. What we want to do next is to set up the test settings. So I'll click on this card on the bottom of the screen. And now I see 3 different inputs which I need to fill. The first one is sample ID, then there is a cluster name, and then operator ID. I will name it sample ID. I'll just name it as chili test. So the cluster is one of the steps of the hierarchy of the Julie. So I will need to verify it where I want to see this report. So if I write it as demo, I will search demo cluster in the Julie and then file my test details there. And the operator ID is my email ID. Now I'll just go back, and then everything is ready. So I will press go to assay. And here I see the instructions, what I have to do this test. The first thing is to select the dilution factor. So this the solution that I have with me is 1 to 100. I'll just click 100 here. And now I will need to place and lock the cartridge. Yeah, done. And I can pipette 50 microliter of the solution. And now I'm trying to not touch the electrode, to not scratch them, and I'm also trying to cover all the surface area. Yeah, this is done. Now I will press start measurement on the top, and the measurement will start right away. And so what the app does at this point, it told the device the measurement settings, and the device is running with this cyclic voltammetry settings. And then once the results, it's running, it's sending the data to the mobile app. The mobile app posts the data in the Julie, where the data gets analyzed. And then after that, Julie sends the results back to the mobile app. Now we see that results are back, and we see 61,000 SHU values. And it says upload complete. Also, I can see green LEDs, which indicates that we can find the data in Julie. Now I'll go to Julie to show where you can find the data. So I searched demo cluster, and I see that I have one. I click on it. My connection is a little bit slow, but yeah, I found it now. And I will click to the MAC address of my device, and I see chili test. The latest report will be my test, and I will click on it and check the raw data. Yeah, we see all 2 scans of cyclic voltammetry, and we also see some results here. And maybe I'll just go back to my mobile app and setup, and I will run one more assay. I will click on the scan QR code, and I have Ginger QR code with me. I'll just scan it. And we see that mobile are set up for the Ginger sensor testing. And we see the Ginger sensor part number, batch ID, and of course assay steps. Now I'll go to test settings to change the name, I will name it Ginger test. And I won't change the cluster name because I want to see them in one cluster. And I'll go back and go to assay. Now I need to choose the dilution factor. It's in this case is 1 to 10, so I don't need to change anything. I will place the cartridge with the sensor and then lock it. Yeah, this is done too. And now I will pipette 15 microliter of this solution. Covered all the electrodes. And now I will start running the measurement. Again, the process is the same. It runs cyclic voltammetry in the Ginger assay too, and we will get results in approximately 30 seconds. But in the meantime, I'll just show you the difference between the cartridge and the sensor. As you can see, it's really hard to handle these small sensors like this. That's why we integrated the cartridges. Now it has a place to hold it. And also we don't have this fear to scratch the electrode when we are placing them in the slots, because in this case, the connection happens on the top of the cartridge. And also we are not spilling any liquids in this case too, because the cartridge acts as a protector for that. And we see that the results are back. We see the results with molarity and with milligram per liter. And of course, we see that the plot was completed. And as a verification, we see the green light. And now I'll go to Julie again. I will need to press this button to refresh. I will get the latest data and see the Ginger test appear. And here is the raw data, 2 cyclic voltammetry scans, and also some analyzed values. Martin, that was all that I was prepared.
Yeah, no, perfect. Thanks so much. So thank you, Gayana. And the reason that we do the live demo like that is because, you know, so much tech, you know, it's always buggy and it's falling down and it doesn't make connection. But of course, we want to actually demonstrate to you that, you know, when we first started this business up, and that was approximately 9 years ago, we actually started building the Julie Cloud then. We've done a lot of medical diagnostic programs, and the hardware has kind of, you know, got better and better over the years. And now we actually have, you know, a nice robust platform. So I'm just going to kind of summarize it and say, if you're on the academic front, we have now done lab instruments that are really similar to the actual instrument that Gayana was showing you today. So if you're academics, we can really get your technology into a kind of product-like format really quickly. And if you're contract guys or your companies that are actually looking to develop new assays or new means of making revenue, then you can all see that this SensiAll platform is, and we use the word OEM in there deliberately so that, you know, we are looking to partner and put this technology into new markets with people who understand those markets and understand the nuance. And we're trying to make it collaborative because we've definitely put the API, the application program interface, in there as well, so that you can pull the data out of our cloud, put it in your cloud, enrich it, you know, and even change the languages, etc., just to kind of, you know, help with that kind of market acceptance. So I do recognize most of the names that have come today, so I do appreciate it. If you've got any questions, most of you I've actually reached out to by email anyway. You have my email address. So I would basically say don't hesitate to reach out to us at ZP. Thank you very much. Thank you very much to Gayana. Appreciate that. Appreciate you staying late in Norway today. I'm speaking to you guys from London. So if you've got any questions, please don't hesitate to reach out to us. But otherwise, I want to say a big thank you to all of you. We've got people from California, East Coast, and in Europe and down in Brazil as well. And okay, thanks very much. We appreciate it. Take care and have a good rest of the day, or have a good evening. All right. Bye-bye.